Okay, good morning everyone. My name's Ian Wright. I'm from Eaton Hydraulics. I'm here to do the presentation on Eaton LifeSense. So you're going to say, well, what is Eaton LifeSense? Well, basically, in this presentation, I'll just do an overview, sort of a value proposition, how the customer would see it, bit of product design and development, how it went through the design phases, marketing material, and a background into what LifeSense is in itself. It shouldn't take much more than about half an hour to go through this. So, in terms of LifeSense, unexpected hose failure is a significant challenge and with serious consequences, and it can be costly. So we look to develop a solution that will help our customers. Come on, join in. So I've just really started. Presented. I'm Ian Wright from Eaton Hydraulics. I'm here to do the presentation on LifeSense. And what I just intended to go through was really a few things, just how it would look as a value proposition to the customer, a little bit on the product design and development, design phases, where we're going with this, and then some of the marketing materials that we could use. I have some samples, I've got some brochures that I can leave with you as well. So I was just saying that unexpected hose failure is a significant challenge with the sort of serious consequences and costly consequences as well. So we look to develop a solution that would help our customers deal with hydraulic power more safely, effectively and efficiently, and this just sort of made sense. So LifeSense actually monitors the hose, and it's not a predictive system, it's actually a continuously monitoring system. So some manufacturers have developed various predictive, so they're working on historical, their knowledge, time-based, whereas this continuously monitors, so it can give you an up-to-date condition of the hose. So it's a condition monitoring system. As I say, quite a lot are predictive in terms of temperature and the flex life cycles, and in contrast, the real-time monitoring of the hose through LifeSense, rather than predictive, gives us a better impact of when the hose is likely to fail, which then allows you to actually run the hose out close to its life end. So in certain instances where you may predict, I think the hose is going to fail, you could be changing the hose out at only half its life or even its quarter of its life, or you could actually get to the point where the hose fails because it's difficult to predict at that point. Bear with me a second, it's frozen the screen. So as I say, a solution to a significant challenge. So in terms of high pressure hydraulic hose systems, it's subject to failure. So the consequences you can see here where this one's failed, it's actually shot a stream of hot oil through into the windscreen of the digger. So the consequences can be safety issues. Oil spillage can give an environmental concern, downtime of the actual equipment, collateral damage, and other associated costs. So in terms of what does this do in terms of product attributes and product benefits, what we try to list quite a few to run through the people. So in terms of the system, we have both a wired and wireless system, which I'll explain a little bit further through. And it's, as I say, it's a continuous monitoring, so it's got a diagnostic unit that continuously monitors the hoses, and the hose sensor detects potential issues, transmits them to the data unit, which can be either a wireless or wired-in unit. At the moment we're running with 2 wire hoses in sizes 8, 12 and 16, and we're actually looking at alert signals that will give an alert in terms of impending hose failure. So the benefits to the customer in terms of those attributes is that it detects and warns of an oncoming hose failure. It provides increased hose life, so if you're changing hoses out just in terms of a manual association, this will actually probably give you over 50% more life in terms of the hose. If you've got a large multi-spiral hose, which can be quite an expensive hose to change out and waste that life, so it's got a cost saving.
Can you just explain, what do you mean by hose failure?
Well, in terms of...
How do you determine that as?
Well, a hose failure can be through abrasion,
No, but what is it? What is a failure? Are you talking catastrophic failure where it actually releases, or a drip of oil, or?
In terms of safeguarding on a catastrophic failure where the actual hose completely fails, you'll see as I work through that how it works, you'll start to see a change when it'll monitor a change in the makeup of the actual hose itself. So again, it's a safeguard as well. So in terms of safety for people, if you've got hoses that are close to where people are working and you can predict to the point to where it could fail, then you can actually safeguard people in the working environment. And again, in terms of that, maximising uptime of machinery and equipment, because in terms of being able to predict when it may well fail, you can actually then schedule in maintenance or changing out hoses at that point. As I say, it improves maintenance operations. So in terms of core benefit, it virtually eliminates hose failure for where you're installing this particular hose, and it reduces cost and waste in terms of replacements of hoses that haven't completed their full life. And a little bit tongue-in-cheek, I guess it's know the moment when your hose needs attention. So in terms of the markets, and you'll see a little bit further on, it's got global potential, and anywhere where a hydraulic hose is being used, or where you see the need to be able to accurately predict when the hose might fail. So really, the LifeSense is cutting-edge technology with a combination of diagnostics and alert system, and a hose condition sensor, continuously monitors the hose conditions via electrical measurement. A diagnostic unit, which is taken up at the top there, alerts the user well in advance of impending hose failure, and a built-in safeguard against sort of like work interruption as well. So the unique Eaton LifeSense hose uses a sensor on each end, which is this device, to pinpoint the problems in terms of the actual hose length itself, and then it relays information to a diagnostic unit that does the interpretation and then puts up an alert. So we can either hardwire it to a unit that will take 11 hoses in one unit, or we can actually do it via wireless signal and feed that back to either our data center, which then can be accessed by the customer to see particular hoses on particular vehicles or particular applications. So where did Eaton LifeSense come from? So it was jointly developed between Eaton and Purdue University, and there's no real other comparable product to the LifeSense in the market today, because as I say, it's a continuously monitoring, condition monitoring hose system. It's unique in terms of it monitors the health of the hose in real time, detecting internal as well as external events, and issue a timely alert the hose is near to the end of its useful life. So in developing this, our customers have shared a great deal of information. Sometimes development is driven by the manufacturer or driven by the customer. It's something the customer spoke to us about, so they've shared a lot of information in terms of cost to themselves. So for instance, if a hose was to fail on a refuse truck, the likely costs were indicated by the customer in this instance, that it could be anything between €3,000 to $40,000 in terms of per incident. So if they could predict when the hose was going to fail, the cost saving is quite significant. You move further down, you put that onto an oil rig. In terms of the cost, if the downtime on a rig is something like about $500,000 a day, just getting to the hose to get it to replace out on a rig could be quite a problematic. Similar thing with downtime in steel mills. And these are all the areas that we were looking to actually put this hose into operation. And in some instances, we're actually running in these environments already. So the life sensor detect and prevent hose failures, internal failure, fatigue, and to impact cycles, and also to external abrasion. So as you can see, the actual sensing of an impending hose failure, so electrical measurement detects the local conditions or local changes. It's monitoring the entire length of the hose. In this instance, we show two designs. You can either have it hardwired, so we can supply it with a fixed length of cable, which will be wired into an electronic device, or you can do it through wireless, and that goes to a gateway monitor. So on the wireless side, we can monitor more hoses, up to 100 hoses from one gateway. On a hard wire, which is mounted more locally, it's 11 hoses per unit. Let's say in here, if you've got an external abrasion, this is what you were looking at earlier. So the two hoses are abrasion together, rubbing through, you get through to the wire. It will start to sense that there's actually a change, and through the predictive process, it can work to the point where it may well fail, because you're starting to actually wear away the wire itself, which is the reinforcement to the hose. Internally as well, if we get changes internally, the measurement sees a change, and then predicted it'll work to the point when it's likely to fail at that point. So in terms of information that we give out, it's sort of limited, but basically you're seeing very much a square sine wave going through in terms of the electrical signal, which has been sort of expanded in the red ring there to give you an overview of it. But as you get towards the failure process, when something starts to change, there's a change within the signal, and through interpreting that through the electronics and the software, we can then predict that the hose is actually in the point of beginning to fail. The one thing that we can't do is, because each hose is used in a slightly different application, that if a hose is used in terms of high impulses continuously, then it may well fail quite quickly at the point where it alerts, or if it's being used intermittently, the time span is a little bit longer at that point. But from the data that we've had from hoses that we've been running, that it's generally around about 95 to 98% of the actual hose's useful life. And then what we recommend from that is that at the point when you receive the alert, that it's changed quite quickly after that. So in terms of historical time-based, to get the most from every hose, most of the hoses would maybe be replaced at a conservative point or replacement of what people perceive to be an average life point. But if you were using the life sense, then you can see from sample 1 and sample 4, it goes way beyond the replacement of the average life. And in terms of replacement of conservative life, there's significant more life out of the hose. And if you're talking of a multi-spiral, a 2-inch multi-spiral, that can be quite significant in terms of the cost saving, and also depending on what machine it's working on. If it was to fail on that, quite a good saving on that machine. So currently we're working on -8, -12 and -16, so that's 1/2 inch, 3/4 and 1 inch hose with a straight jig fitting on the end where the life sensing piece sits. The hose itself is significant to the life sense, so you can't take a standard 2-wire hose and put the end cap on the life sense end cap. It's actually a specific hose for this application. You can put a standard fitting on the opposite end. So when we were developing this, we enlisted quite a little bit of help from our customers in various areas of the world, and we've done different sort of applications. So we've got it onto impulse machines, tube benders, robotic machinery, injection moulding. Refuse truck was a big project. The latest one, we put it onto a golf turf equipment machine, into the steel mills and also out onto the rigs. We're still looking at different applications. If somebody came along and said, I've got this application, it's slightly different to what we've already currently done, then we'd be interested in working with somebody as a project to run that through. So as an example, and I'll use this example further through, so on a refuse truck, this was in New York State, first installed in 2011, we've got 40 pieces of equipment, 300 hose assemblies. So far we've received 37 alerts, of which 26 were abrasion alerts, 9 were fatigues and 2 external damage, and we've had 0 failures where we've put this on, which in terms of the time scale, you'd probably be thinking that there would have been some failures, but with the life sense, we've actually seen no failures in that particular time. And if you go back to my other slide, where for a refuse truck, if it's 3 to, I think it was 7k, no, it was 7k in terms of the cost. If it failed out in the field, it's a significant saving. We've rolled that out not only into New York but across a couple of areas of the globe as well. So one of the other ones which is a recent success is on the Greenbrier, which is a golf turf machine. So the customer there, you've got a lovely nice green. The last thing you want is when you're actually just mowing it for an oil or an oil drip right on the green. So by putting the life sense hose, they can predict when the hose is likely to fail. They can put a maintenance program in. They can get that changed, get the machine back out there quite quickly with no real fear of damaging the greens. We've just recently installed, so if you go down into the workshop, you'll see one of the hoses installed down in the workshop here as well. So when we originally started out, we had an outer shell that was just out of nylon 66. It actually snapped together, and it had limited sealing. So we've moved on from there. We've developed it. It's now a screw enclosure. We've slimmed down the design. It actually will fit instead of fitting around the hex of the fitting, it actually fits around the shoulder, so it fits on a radius. And we put some O-reel seals and gaskets in to give it a higher IP rating. I've got a sample here that I can show you very shortly. So this was really the roadmap of where we were going with this. So in terms of what we're up to, we've got today we're with the wired and up to 11 assemblies into one wired unit, which is the hose diagnostic unit, which we call the HDU. We're working on the 8, 12 and 16 2SN hose. At the moment it's factory assembled because we want to make sure of the quality. We want the product to be out there fitted correctly. We're working with just straight JRC connections. So as we move forward, and we're actually into this in terms of wireless notification, so we can actually, information is sent wirelessly back to a hub which can be accessed through the Eaton portal. We're starting to develop with our TTC fitting, which is a through the cover fitting, a one-piece fitting, and we're expanding in terms of the type of fitting that can go onto the end of the hose. We're starting to roll out in different sizes, so we're going for 1/4 and 3/8, and then obviously 12 and -16 in an R12 version. So again, the program moves through. We're still looking at factory assembly, and we're looking at wireless onto the 100R12. The idea in terms of the final version is that we'll have a range of hoses that will have the LifeSense facility to go with it. It'd be basically battery-free wireless on all terminal ends, on all different configurations, and end-user assembly. Once we're happy that we've got good field results, then through designated distributors, you'll be able to they'll be able to assemble. So it doesn't have to go back to the factory to be assembled. So I was referring to the wireless application. So the program that we're running in New York with the refuse vehicles is the one that we've started to run with the wireless. So the trucks are fitted with the LifeSense hose. They're fitted with a unit that can send a signal, which effectively comes all the way back to an Eaton portal, and from that the customer can access that, and you can see which vehicle, well, in actual fact, which state, which vehicle, which hose, and what's the condition of that hose. So as the truck is out, it's monitoring continuously while it's out working. When it comes back, they've already got a good idea if everything's okay. If there's a hose that's been alert, they can get onto that, get that changed out pretty quickly, and the truck goes back out again. So as I was saying, the sensor data is sent to the gateway on the truck. The gateway collects the data and transmits it through an access point. The access point then transmits to the server, and the server processes that data. So in terms of what can be done, the failure notification to multiple parties, so that can be sent to the maintenance, it can be sent to the customer. It has a system of trend reporting, so you can see if you have a trend of a particular hose on a particular truck. Therefore, in terms of monitoring one, we can monitor several trucks within the fleet. And again, as I say, it enables advanced system monitoring and diagnostic, the point being to save downtime, to save spillage, and as a safety aspect. So anybody who's using the wireless system can have access to the data. So they come onto the Eaton site, they'll have a password to get into their supply. So as I said, you can have the customer name. You can have the region, so in here we've got Indiana and Ohio. We look at the Columbus site, we look at the gateway, so that's the vehicle that it's coming from, and we can see the sensors. So these are 2 hoses, and we can view the status, so it's saying that the hose is good, connection status needs to be checked, battery is okay because it's got its own battery being wireless, but it's advising on this hose that it gets replaced. So that's an information that's fed back to the maintenance team. They'll replace, they know which hose it is that needs replacing. So we have a whole range of marketing material for this particular product that we feed out to the customers, and also in terms of if there's an interest in actually an application or a different application, then through either myself or through one of our distributors, we can put in a request for hose samples, or we needed a certain amount of information to run with that.